Have we reached the inflection point for quantum computing? Executive summary. Quantum computing is nearing a major turning point, shifting from research to real-world applications. Advances in qubit reliability, error correction, and scalable designs are driving rapid progress. Companies like IBM, Microsoft, and NVIDIA are investing heavily, while cloud-based quantum services expand access. However, fully fault-tolerant systems and proven quantum advantage remain out of reach. Despite technical and economic challenges, growing investment in hardware breakthroughs suggests the field is entering a transformative phase with commercial potential. Article: Quantum computing is getting close to a major turning point, shifting from mostly research to early real-world use. Improvements in qubit accuracy, error correction, and scalable designs, like neutral atom and trapped ion systems, are speeding up progress. Major companies such as IBM, Microsoft, NVIDIA, and Quantinuum are investing heavily, and cloud-based quantum services are becoming more common. Still, large fault-tolerant quantum computers haven't been built yet, and true quantum advantage over classical computing hasn't been proven. Despite the technical and financial hurdles, growing investment, company consolidation, and breakthroughs in hardware suggest that quantum computing is entering a crucial stage, one where steady progress could soon make it both scientifically and commercially transformative. In quantum computing, an inflection point could mean quantum advantage. A quantum computer outperforms the best classical computer on a real, meaningful task. Commercial adoption. Quantum computing starts providing real economic value in areas like materials science, logistics, finance, chemistry, or cybersecurity. Scalability and fault tolerance. Demonstrating reliable, error-corrected quantum systems with many logical qubits. Ecosystem maturity. Strong hardware, software, funding, talent, and collaboration, forming a self-sustaining cycle. Signs that quantum computing is nearing an inflection point. 1. Shifting industry sentiment. Leaders like NVIDIA's CEO Jensen Huang have said that quantum computing is reaching an inflection point. Many reports describe 2025 as a turning year where the technology becomes more deployable. Investment patterns also show consolidation. Fewer, larger funding rounds that focus on scaling rather than spreading bets. 2. Hardware advances. Progress in qubit stability, connectivity, and control continues rapidly. Neutral atom and atomic array systems are expanding their scalability, while companies like Quantinuum are setting records for quantum volume and gate fidelity. Microsoft has also introduced the Majorana 1 chip, an early step toward topological qubits, though its claims are still being verified. 3. Growing commercialization. Quantum firms are moving from lab demos to real customer contracts and partnerships. Quantum-as-a-service platforms, via the cloud, are making the technology accessible to more industries. 4. Expanding market and investment. Forecasts predict major growth in the next decade, and tech giants are increasingly treating quantum computing as a serious next frontier. Why we're not quite there yet. Despite the momentum, several challenges still hold quantum computing back. 1. Error, correction, and fault tolerance. Building large, reliable quantum systems requires enormous overhead, millions of physical qubits, to create a few stable logical ones. True error correction is still out of reach. 2. Scaling and control issues. Managing and connecting large numbers of qubits without interference is a huge engineering challenge, especially as systems grow. 3. Limited real-world quantum advantage. While lab demonstrations have shown small-scale quantum wins, they haven't yet translated to broad, practical use cases. 4. Economic uncertainty. Quantum startups often depend on future potential rather than current profit, and technological risk remains high. 5. Hype versus reality. Media and investor enthusiasm can exaggerate progress. Distinguishing true breakthroughs from hype will take time. The bottom line, inflection in progress. Overall, we're entering the inflection zone, but haven't fully crossed it. Investment, innovation, and pilot projects are expanding rapidly, but we're still waiting for quantum computing to deliver consistent, large-scale advantages. The next few years will be decisive. They'll show whether this momentum leads to lasting transformation or stalls under technical and economic pressure. In short, the inflection point is forming, but its full impact still lies ahead.